Hello, welcome to this video on tree diagrams and probabilities. Most of these are dependent situations, but it's just practice on reversing the condition as well as reading and making tree diagrams. Up above on this worksheet that you guys have, you should have links to it if you're in my class. They have it blank, right? But I'm going right to the answers and I'm just trying to explain everything that's going on here. So on this first one, it's a university professor and he's failing students. 20% of his students fail the final. Um, and then after the final, he polls these kids and says, how much did you study or you didn't study? So 80% of the kids passed, 20% failed. He went and asked them. If they failed, 31% studied. But if they passed, that was 72% of the ones who passed studied. So there were still some kids who didn't study but passed, and still some kids who did study but failed, right? So you can look at that. Now, what I'm looking at right away is I'm noticing that these probabilities, the studying probabilities, are different depending on whether you passed or failed. So I immediately know this is a dependent situation. The probability of you studying depends on whether you passed or not. There's a connection there, right? So they're not independent. They are dependent on each other. And you could write this the other way, I guess, right? Where you have the chances of you passing is different whether you studied or not. But that's what reversing the condition is for, which we'll see. So let's get to the questions. What's the probability a student studies? Well, you'd think right here it's, this 72% or something. Well, wait a minute, it's 31% down here. So which one do we use, 72 or 31? Well, neither one, to be honest. What you have to do is you have to look at the overall probabilities in each case. So this 57.6 is the probability that they passed and studied, and the 6.2% is that they failed and studied. In both cases, they studied, right? So what's the probability that a student studied? Well, you just add them together. So it could be this situation, or it could be this situation. When you hear the word or, that means add them together. So 57.6 and 6.2% added together give you 63.8%. Okay, part B is a student doesn't study. What's the probability a student doesn't study? Well, that's just this and this. Those are the two places where students did not study added together. Again, you can't just go 28 plus 69. That's not going to make any sense. You can't pick the 28 or the 69 by themselves either. That doesn't make sense. You have to follow it through and add the pieces that include not studying. Remember, this whole column is where it equals 100%, right? If I added all these together, it would equal 200%. So it doesn't make any sense to be adding like this and this together or something. It doesn't make sense. You have to wait till you get all the probabilities out on the end, right? So this is where it equals 100%. Okay, so 22 and 4, 13.8, add them together, you get 36.2%. Now this is where we reverse the condition. So if a student studies, so this is like a given, right? So given that a student studies, well, we already did that one, right? That's where a student studies, that's the 63.8%. You can see that on the bottom. So given that a student studies, what's the probability that they had actually passed the test? Well, okay, so the passing piece is this out of the total of the people who studied. So that's why you see the fraction the way you do is the overall how many people studied or the percentage or probability of studying. And then from that, how many passed. So it's the 57.6 out of the 60.8, which gives you the 90%. Right? So think of these as givens, right? So what's the probability someone passes given that they studied? Okay, part D, same situation kind of. So if a student studies, so in other words, given a student studies, all right, they study, same thing again. That's the 63.8. And then what's the probability they failed? So in this case, now we're talking about of the studying ones, this is the one that failed. So that's the one that goes on top and you get your 9.7%. These two should be complementary to each other and make 100% because obviously they're both from the studying group, but one is passing, one is failing. Okay, and then same thing here, but kind of reverse now. So it's like, okay, let's talk about given a student doesn't study, right? So now we're talking about this and this together, which is your 36.2. What's the probability they fail? Well, this is the part that failed. So that's what's on top, 13.8 over the 362. So that gives you a probability, total probability of 38.1, right? Same thing here. This is 38.1. This has to be the complement of it because this is passing and this is failing, but with the same given, right? Same given. All right, so take a good look at that. You can, of course, pause the video and take a better look. All right, let's try the next one. Take a good look. I'll go a little faster now since you got the idea. Just maybe point some things out. Quickly, I'm just saying, oh, these are dependent. This is Lyme disease situation, right? And I like this situation because this happens in the real world all the time, where maybe it's an HIV test or some test for some disease. Right now we got COVID going on. I'm sure the tests, when they come up with a test or when they're using the test, it's not 100% accurate, right? There's probably once in a while, somebody, the test says they have COVID and really they don't, or vice versa. Sometimes it says, they don't have it when they really do. All right, that happens from all the time in the world when you're giving out tests for different things. Sometimes higher percentages than others. Sometimes the test can be really accurate. Sometimes they're not so accurate, depending on what it is. Okay, but hardly any test is 100% accurate, almost never. Anyway, so this is for Lyme disease. So you get a positive reading, negative reading on a test for Lyme disease, right? So if you have Lyme disease, if you really have it, the test will give you a positive reading 97% of the time and a negative reading 3% of the time. So it's giving you this kind of false feeling 3% of the time where you actually have it, but you think you don't. And then the other one, if you really don't have it, 92% of the time it gives you the correct reading and gives you a negative reading. But 8% of the time it gives you a positive reading, even though you don't have it. So you think you have Lyme disease, but you really don't. That's 8% of the time here. But in general, you gotta put everybody together, right? So let's look at the questions. So a probability a person gets a positive reading. So just you go in and say you think maybe you have Lyme disease, but you don't really know. That's why you're taking the test. So you don't know these two categories, right? You just don't know. So that's why, that's another good reason why we have to group these together. So what's the probability a person gets a positive reading? So you might think, well, this is the real truth. These are the people who got a positive reading because they really do have Lyme disease. So isn't it 3.8%? Well, no, because these people got positive results as well, even though they didn't have it. So the probability of you getting a positive result is 11.56%, right? So you're adding those two together to get this 11.56%. Right? You don't know. So if you're in that category, you still really don't know if it's because you have it or because you just had a wrong reading, right? An incorrect reading. There's still that chance, right? So the person gets a negative reading. What's the probability you get a negative reading? Well, again, it's not just a single, it's both of these together. So you have to add those together and get 88.4% chance, right, that you get a negative reading. And remember, included in those negative readings are people who actually have Lyme disease. All right, part C. If the person gets a positive reading, what's the probability that they actually have Lyme disease? So positive reading is the total, right? These two. So this plus this gave us our 11.56. So that's on the bottom. So out of those people who got a positive reading, what's the probability you actually have the Lyme disease? Well, actually having it with a positive reading is 3.8% here. So you do that division. So if you go into the clinic or whatever, and you say, I'm not feeling well, I think maybe I have Lyme disease, and they give you a test and it comes back positive, what's the probability that, even though it came back positive, what's the probability that you have Lyme disease, right? And it's 33.6% chance that you actually have it. Very strange, right? Very strange. It's just because this positive reading for no Lyme disease is quite high. It's like 7% chance that you don't have it, but it says you do. That's quite high. So if it gives you a positive reading, the doctor might say, well, you really, there's only still a 33% chance you have it. So we're going to do some more tests or give you a second test or something like that, right? That happens all the time. All right, so the probability if a person gets a positive reading, so you get a positive reading, brunk, brunk, right? You add those together, 11.56. And then you want to know that you don't have it, right? So this is just the complement of this one over here. So if that was 33, this is 66% chance. Very strange feeling, right? You got a positive result, but there's still only a 33% chance you have it. There's a 66% chance you don't have it. And I'm sure the test is set up that way so that you'd rather err in the direction of telling someone they might have Lyme disease and then checking it out further versus someone who actually has it and then you tell them they don't and they go away thinking that they don't have it. You don't want that situation, right? You'd rather have the other way. So you're going to see down here the difference. So now this one says, okay, you get a negative reading, right? You get a negative reading. So negative reading, negative reading. And we know that's an 88.4% chance, right? 88.4. Okay, so that's on the bottom here. And then out of that, what's the probability that you actually don't have it, right? So you get a negative reading, but you actually don't have it. So that's 88 out of 88 almost. And you get this really high percentage chance. And the test is set up that way. It's like, okay, if you get a negative reading, we're 99.8% sure that you really don't have it. But if you look over here and you do the other probability, there is a slight 0.1% chance that you actually do have it, even though the test came back negative. People are willing to live with this because that's probably the best they can do with the test. That's okay, right? We wouldn't want it reversed. We wouldn't want it where 66% of the time you get a negative reading, but you actually have Lyme disease. We don't want that. That wouldn't be very helpful, right? So this is what we're looking for. If you get a negative result, then we're pretty sure you don't have it. If you get a positive result, we're going to do more tests and we're going to check it out to really see if you have it or you don't, because we know the positive result is not very accurate, right? But the negative result is. And this is a very good problem because of that, the reality of this happening in the real world all the time, right? This happens all the time. All right, great problem. I'm not going to go through any more, really. I'm just wanted to point out on this next problem, number 3, this is supposed to say 85% chance. So when you're looking at these numbers, hopefully that makes sense. It's just the idea that on a true-false test, that if you know the answer, you're going to get it correct. And they say you know the answer 85% of the time. So that's just a straight 85. And then if you don't know the answer, which is 15% of the time, you're going to guess at the answer. And because it's true-false, it's just going to be a 50-50 guess. So that gives you these probabilities, right? And then you can answer questions on that. Then the last one, this is a really good problem too, just because it kind of mimics what's going on in colleges. They're trying to say like, okay, if you have a high SAT score or at least something over 1400 or whatever, that they're going to take a further look at you. But if you have a low SAT score, they're not even going to look at you and you're done, right? And then as you go on, then it branches off, right? Okay, next, if you made the SAT cut, they're going to look at your GPA cut, yes or no, based on GPS. Well, actually, it's yes, no, or I'm going to look at you even further, right? So it's broken into 3 categories, and you get these dependent situations going on, right? This is a really good problem, right? So if you still haven't made the cut or you haven't been cut, then you got one more chance. They're going to read your essay. So they look at the SAT, they look at your GPA, and then they're going to look at your essay. So after all that, if they like your essay, then they'll accept you. If they don't like your essay, then you get rejected. So you get 3 places where people got cut and 2 places where you got accepted. And then you can answer the questions on those, right? So probability you're going to get accepted to the school. Well, just if all things are equal, there's a 38% chance you're going to get accepted to the school, making it on the like right away with the GPA or making it through the essay section, right? And you can go through all those probabilities. I'll just leave it there for a second, and you can pause the video and kind of run through those. And hopefully you get used to reversing the condition when you're doing those given situations, right?